Welcome to today's deep dive. We are getting into something that I think is going to save you a lot of headaches. We're talking about securely offloading massive file transfers in your cloud architecture, specifically without completely breaking your backend.
Yeah, which is something so many developers struggle with. It's a really common trap.
Oh, absolutely. And we have a great source for this today. We're pulling from a blog post on tech-reader.blog by software engineer and writer Aaron Rose. It's called The Secret Life of AWS, the direct handshake, referring to Amazon S3 pre-signed URLs.
It's a fantastic read. He actually frames this deeply technical cloud architecture lesson inside a really fun, relatable narrative.
Right. So the mission for our deep dive today is to extract that practical lesson from his story. We want to show you how to save yourself from those, maddening latency spikes and wildly inflated compute costs.
Yeah, because those cloud bills can get out of hand really fast if you aren't careful.
For sure. So to set the scene, Aaron Rose places this whole scenario in this grand Victorian library in London.
Yeah.
Imagine towering mahogany bookshelves, the smell of old paper. It's this environment where code craftsmanship is taken very seriously.
It's very atmospheric.
Yeah. And in this library, we meet our two main characters. There's Margaret, who is this incredibly wise senior engineer, and then there's Timothy, her junior colleague, who is currently very frustrated.
Understandably so, based on what he's looking at.
Right, because he's just staring at his screen, which is flashing this glaring red HTTP 502 bad gateway error. Okay, let's unpack this. Timothy's dilemma is actually pretty straightforward on the surface.
Right, the marketing team just wants a simple feature.
Exactly. They want customers to be able to download these really high-resolution, beautiful 15-megabyte PDF manuals for a line of custom keyboards. But Timothy's staging environment is just completely choking on it.
Yeah, and the architecture Timothy set up here is, it's incredibly common. That's why this is such a perfect case study.
So what exactly is he doing wrong?
Well, he has an API gateway acting as his front door. When a user clicks download, that gateway triggers an AWS Lambda function. Then that Lambda function reaches into a private S3 storage bucket, pulls the entire 15-megabyte PDF into its own memory, and tries to shove that massive binary file back out through the API gateway to the user.
And it just crashes.
Catastrophically.
But, I think a lot of developers look at AWS, which markets itself as this infinitely scalable serverless beast, right? And they look at a 15-megabyte file and think, well, AWS handles Netflix streaming. It can definitely handle a keyboard manual.
You would think so, yeah.
So why is this specific flow causing a 502 bad gateway error?
So it really comes down to the physical limits of the services involved.
Okay.
Specifically, API gateway payload limits.
Oh, okay.
API gateway is an amazing, resilient tool, but it is explicitly designed for high-velocity, lightweight traffic. We're talking mostly small JSON text messages. Because of that design philosophy, AWS enforces a hard, non-negotiable maximum payload limit of 10 megabytes.
Yeah, 1 megabytes.
Yeah, on both requests and responses. So routing massive binary files, like PDFs or videos, through an API designed for lightweight JSON, it's a huge architectural anti-pattern.
So Timothy's 15-megabyte file is literally just hitting a brick wall. The gateway drops the connection because it's physically too big for the pipe.
Precisely. But here's the thing. The payload limit is just a symptom of the larger problem. Even if that PDF was, say, 9 megabytes and it technically fit, routing it through a Lambda function is still a terrible idea.
Because of the cost.
Yes, compute costs and latency. Serverless functions bill you based on memory consumption and execution time. To pull a large file into Lambda, you have to provision a lot more memory. Plus, that function has to stay awake and billing you for the entire duration of the download.
Oh, man. So if a user is on a terrible 3G mobile network,
your Lambda function is just sitting there spinning its wheels, burning your compute budget, waiting for that slow transfer to finish.
That is brutal. And Margaret, the senior engineer in the story, actually catches him doing this. She uses this brilliant analogy. She tells him, you are using a sports car to haul a tractor.
It perfectly illustrates the mismatch.
Right. The API gateway and Lambda are Ferraris. They are built for extreme agility, spin up in milliseconds, do some quick math, and vanish. But Timothy hitched a giant John Deere tractor to the back bumper of the Ferrari, and he's wondering why the transmission is smoking.
Exactly.
But this does bring up a really big question for me. If APIs are so obviously the wrong tool for heavy lifting, why do developers like Timothy instinctively try to shove 15-megabyte files through them in the first place?
Well, the answer almost always comes down to one word: security.
Right.
Developers use APIs because they act as a secure, programmable front door. You need a place to verify the user's identity before you just hand over your proprietary data.
Which is exactly how Timothy defends himself in the story. If he stops routing the traffic through his Lambda function, his only other obvious option is to just make that S3 bucket completely public.
Which you absolutely cannot do.
Right. The 502 errors would go away, sure, but now he has a massive security breach. Any bot on the internet can scrape all those proprietary keyboard manuals in minutes. He needs the Lambda function to act as a bouncer at the door.
Yeah, that's a very valid fear. The bouncer needs to check the user's IAM token or their Cognito JWT to verify they actually bought the keyboard.
Right.
But what's fascinating here is how Margaret separates those concepts. She validates his security instinct, but she challenges the data flow. She explains that lightweight, compute-heavy tasks, like validating that authentication token, absolutely should happen at the API layer.
The bouncer stays at the door.
Exactly. But the heavy data transfer shouldn't happen there. She separates the concept of authorization from the concept of delivery.
Okay, I get that in theory. Keep the bouncer, but let the bartender S3 serve the drink directly. But mechanically, how do you do that? How do we keep the bouncer but bypass the API layer for the heavy lifting?
This is where Margaret introduces the S3 pre-signed URL. It's a really elegant solution.
Okay, walk me through that.
Instead of Lambda trying to carry the file itself, it uses its own secure IAM role, its internal AWS permissions, to basically forge a temporary cryptographic VIP pass.
That's the URL.
Right. It hands this URL back to the customer's browser, and then the browser uses that pass to go straight to S3 to pick up the file.
Wait, bypassing the API layer entirely?
Entirely. The client browser goes straight to S3, and it doesn't even need its own AWS credentials to do it.
Here's where it gets really interesting, because in the story, Aaron highlights this mind-blowing size reduction. By utilizing this pattern, Margaret takes Timothy's massive 15-megabyte payload bottleneck, and she reduces it down to a tiny 200-byte JSON response.
It's incredible.
Right, it just contains that tiny download URL string.
Yeah, we call this the offloading pattern. The API gateway is no longer acting as a congested freight tunnel. It's just handing out directions.
So the Ferrari just drives the keys out to the tractor driver.
Exactly. And this keeps the serverless backend lightning fast. The Lambda function wakes up, verifies the user, generates the URL, sends it back, and goes back to sleep in milliseconds.
But wait, handing out VIP passes is great, but how do you make sure the guests don't misbehave? I have some questions about the user experience here.
Sure. What's on your mind?
Well, if it's just a raw S3 URL, won't the browser just try to open the PDF inline? Like instead of actually downloading it to the computer like the marketing team asked for?
That's a great point. Yeah, browsers naturally want to display PDFs and images right in the tab.
And that's super annoying when you want to save a manual.
Right. But this is where the granular control of the pre-signed URL comes in. When Lambda generates that VIP pass, it can actually embed specific HTTP headers into the signature.
Oh, really?
Yeah. Margaret uses a parameter called response content disposition and sets it to attachment. So when the browser goes to S3, S3 essentially tells the browser, hey, don't open this. Download it as an attachment.
Oh, wow. So it forces the download. That's super clever. But what about security? Like, what stops a user from taking that VIP pass URL, posting it on Reddit, and suddenly 100,000 people are downloading your manual?
Yeah, you'd blow through your AWS data transfer budget in an afternoon.
Exactly.
This brings us to the time to live, or TTL.
Yep.
Margaret uses the expires in parameter.
Right. I think in the post she sets expires in 300, which is exactly 5 minutes.
Yes. If we connect this to the bigger picture, this is how you maintain control. Those strict expiration windows completely prevent permanent sharing, scraping, or any kind of abuse.
Because even if they email it to a friend, it's useless 5 minutes later.
Exactly. S3 mathematically verifies the timestamp when the request comes in. If a single second has passed beyond that 5-minute window, S3 just drops it. It returns a native 403 forbidden error.
Man, that's ruthless, but in a good way.
It is. And what's really cool is this exact same pattern works in reverse.
Wait, for uploading?
Yep. You can generate a pre-signed PUT URL. So if you need customers to upload massive files, like, say, a 2-gigabyte support video.
Oh, you definitely don't want that going through API gateway.
Never. You generate a PUT URL, and the customer's browser pushes that massive video directly into S3. The API never touches it.
That is brilliant. So what does this all mean? I mean, for you listening, it comes down to adopting this offloading pattern. It allows you to keep your architecture highly secure, incredibly cost-effective, and blazing fast. You don't have to choose between a secure backend and a performant one.
You really don't. And, thinking about this story and the mechanics of it, it leaves me with this broader, almost philosophical thought.
Oh, I like where this is going.
Well, think about how much of our digital world relies on the illusion of permanent location versus temporary permission.
What do you mean?
Well, a URL literally stands for Uniform Resource Locator. We're used to it being a static pointer to a permanent home.
Mm-hmm.
But with this architecture, it's not a location anymore. It's a fleeting 5-minute window of cryptographic access that simply evaporates into thin air.
Wow. Yeah, it just stops existing.
Right. And when access evaporates like that, how does that fundamentally change our concept of, owning or sharing a digital file?
That is a fascinating question to leave on. If the bridge to the file burns itself down after 5 minutes, did you ever really share the location at all?
Exactly.
Wow. That gives you all something to mull over. We highly recommend checking out Aaron Rose's post for the exact code snippets. Thanks for joining us for this deep dive, and we will catch you next time.